Alright, however, I want to give you some help on set D. First problem right here, 31. These are the ones people asked about. Number 31, you have to find the definite integral from here to here, and you have this function here, and we always want to try and simplify it. And what you could do first is you could factor this top, and this top that's the difference of squares, right? And the bottom is just another x plus 5. So these will cancel out, and then you can just do the integral from here. And if you just work with that integral, go ahead and do that. Of course, you can take that up and get x squared over 2 minus 5x, and all of that from here to here. So do that, factor it first, simplify it, and then do it. It does ask you first, I think this is part B, and then part A says what values are not part of the domain. Well, x is equal to negative 5, and we'll talk more about this later, but can't be negative 5 because that zeroes that out. And so this is a restriction on the domain, but you can still go ahead and take the integral here. Had a question on number 40. 40's easiest done is if you just take this and rewrite it as x to the negative 3 plus x. And then when you integrate number 40, right, this is add 1, so that would be x to the negative 2, divide by negative 2, and it's plus x squared over 2. Take that, you have some work to do with fractions, but you'll get that. Or you can just do them separately if you want to and put them together. On 44, it asks you to integrate this, and it says 0 over, and it doesn't tell you where to end at. So it tells you to start at 0, but it doesn't tell you where to end at. And this is a problem you would be able to use a calculator for. You'd have to solve it. But this function does is it goes down and it touches at 8. So what you have to do is just integrate this fraction from 0 to 8. I mean, integrate this expression right here. So finding that 8, we'll talk about it later in the course, how to find the 8, but graphing on the calculator, you'll see it's here at 8. If you didn't have a calculator and you had to do this, you'd have to solve this equation set equal to 0, but I'm not going to put that on the quiz or the test tomorrow, so go ahead and do it that way and just integrate that. Just same steps as this one and take it over 0 to 8. This one obviously looks like the chain rule, right? You take the derivative of sine, which is cosine. So if you let u equal sine of x, that means the derivative is equal to cosine of x, and you could put that over there. And now this looks exactly like that right there. So that can go out for du, and this is u to the third du, and now just integrate it. And the rule is add 1 and divide. A lot going on here, but if you notice, if you have this here, the derivative of this is just x plus 1. So if you let u equal x plus 1 squared, then du dx is equal to a 2. Drop that down in front, keep this the same, chain rule type of thing, multiply by 1, but you just take this down, subtract 1, and now we have this to the first power. And if I divide this over here, multiply that over there, now what I have right there is exactly what is left in here. So this can come out. I'm going to pull this constant out to the front, and this can go away, and that in its place would just be the du. Whoops, and I'd have a 5 to the u du. Integrating this, that's 1/2. What do we do? 5 to the u stay the same, just like integral of e to the x is just e to the x. That's an exponent right there. And just like the derivative of e to the x is just e to the x. So it's the same thing with the variable as an exponent, so it stays the same, but this is always divided by ln of e, and it's multiplied by ln of e, which is 1, but it's not 1 here, it's ln of 5. And I guess this is an indefinite integral, so we'll leave it alone, and we will add on the plus c there. So just when you have these exponential equations, that's the plan for them that way. And then you can go ahead and put this back in right there. All right, on 70, looks like a straightforward substitution. The best substitution here would be u is equal to x squared minus 8, because once you take the derivative, now you have, whoops, that goes away, doesn't it? Now you just have 2x. And take that over, whoops, say 2 dx, and there's an x and a dx. Whoops, I got rid of the 2. So there's everything you need there. Whoops, let's write it the right way. An x dx. There's everything you need there. There's that, and you can have the square root here. I'll go ahead and finish this. Let's pull the 1/3 out. 3 to 6. This is just du with got another half out there, so don't forget about the half. And what do I have in the bottom? I pull that out. Well, I have the square root of u. I'd probably clean this up and write it like this, and u to the 1/2. Square root of u is a half, but it's in the denominator. So that's where I'd go with that. It's u to the negative 1/2 du from there. All right, and a question on 80. This integral right here is not one that we really worked on, but it's on the sheet, and you'll have that sheet for your test, and you can just leave this alone, and the integral right here is simply, well, let's take it one step first. First we need to deal with this right here. So we need to say u is equal to theta divided by 3, and let's take the derivative. Derivative of x is 1/3, because that's a variable. And now 3 du is equal to dx. I should have called this d theta. All right, so now that we have that cleaned up, let's go ahead and clean this up here. So now I have a tangent of u, and the du is a 3 and du. So I dealt with this, and it's divided by 3, so we have to do stuff backwards just to be careful. We're going to do all this. So now I've changed it to the tangent of just u by itself, and that's one that we have not memorized, but one that's on our sheet. And on our sheet, the tangent of u is simply the negative natural log of cosine of u here. And again, that's not one that we've worked with a lot, but it is on the reference sheet, and you'll have that for your test. So the tangent of u is the negative natural log of cosine. Then you can put it over that, and then now you just have to integrate it over here. But one thing we did is we switched to u, so you can go ahead and switch these. I guess I didn't here. Let's see here. U is theta divided by 2, so it used to be pi, but now I'm going to switch it. Once I switched to u, I should have switched it right there. It's pi over 3, and this is 0 over 3, because once I switch it to u's, I might as well switch these to u's, so that way I can leave the u in there. And then now you can just do the work with cosine. Both of these can go in there. And I'm going to go ahead and write it out since I forgot to do it. But it's 3 natural log of cosine. And just put in the cosine of pi over 3. And the cosine value, if you have a right triangle and you're doing pi over 3, the cosine value here is 1/2 minus a negative natural log, and if I'm doing the cosine of 0, the cosine, let's see here, at 0 degrees is out here. This point is 1, 0. Cosine is 1. So make sure I left the negative inside here, so those are 3. So it's a negative one of these minus a negative one of those right there. And the way this simplifies is this is negative 3 and this is natural log of 1/2. Well, this over here, the natural log at 1 is just 0, so this is going to be gone, and I'm going to be left with a negative 3 ln of 1/2. And that's a good answer. But I'm going to show you how to simplify that a little bit. Remember, the one thing you want to look for when you're simplifying natural logs is exponents. So can I rewrite this as an exponent? Sure. That is negative 3 ln of 2 to the negative 1 power. Because remember, a negative 1 power makes it a fraction. So now that that's an exponent, I can bring it down. And the most simplified version of this is 3 ln of 2. Now again, I'm going to give you most of the credit for here, but if you can think about changing this 1/2 into an exponent that's 2 to the negative 1, then you can pull that exponent down and clear that out. And try that on your calculator. If you type this in your calculator and this in your calculator, you'll get the same answer. But always try to get rid of these fractions here. And the only way we know how to do that with logs is this rule that allows you to bring down the exponents. Alright, I hope this helps on these problems for set D and your test tomorrow.